And actually, we can say a little bit more about this augmented matrix. It's not only in row echelon form, but it's actually in something called reduced row echelon form, which means it satisfies an extra condition, which I'm going to write down below. And let's say we're going to extend this definition. So this definition that we wrote down tells you what row echelon form is. A matrix is in row echelon form if it satisfies these three conditions, and is in reduced row echelon form if it satisfies this extra condition. And just like with row echelon form, we abbreviate reduced row echelon form. So we just put an extra R. So RREF is an abbreviation for reduced row echelon form. So what is the condition? Let's just take a peek up at this matrix first, and then we'll write down the condition precisely. Notice that if you look at every one of these leading ones, if you check the other entries in the column, so columns are vertical. Remember, in this course, that's really important, by the way. Rows are horizontal and columns are always vertical. So in some contexts, you may not need to distinguish between the word row and the word column, but in this course, the distinction will be very important. So columns are always vertical. So if you look at the other entries in the columns for each of these leading ones, they're all zeros, right? Here's a leading one, the other two entries in that column are zero. Here's a leading one, the other two entries in the column are zero. And same with this one. Here's a leading one, and these two entries are zero. So that's the extra condition. So if each leading one is the only non-zero entry in its column, so that is what it means to be in reduced row echelon form. Okay, let's look at a couple of examples. That will help a little bit more, because they actually don't always look quite this perfect with ones going straight down the main diagonal and zeros everywhere else, as we'll see momentarily. So I'm going to start with some examples of matrices that are in row echelon form. So I'm going to jot down a couple of matrices here. And I'm actually, well, let me write down one of them first. So here's one, and this is going to be an example of something called a 2x3 matrix, because it's got 2 rows and 3 columns, right? 2 rows and 3 columns. And you'll notice I used a symbol here, an asterisk, instead of a number. And whenever I write that for this example, that's intended to mean just a wildcard entry. So in other words, it can be any number at all. So wildcard entry, just to be clear. So let's check that this matrix is actually in row echelon form. So what I mean by this wildcard entry is no matter what numbers you put in place of these 2 asterisks, this will be in row echelon form. So let's check the conditions one at a time. So the first condition says that all the rows of zeros must be at the bottom. And, well, in this example, there are no rows of zeros, right? So the first condition is automatically satisfied. The second condition says that the first non-zero entry of each row must be a 1. Well, let's just go through the habit of circling the first non-zero entry of each row and make sure that they're 1. And they both are, right? Here's a 1 and here's a 1. Those are the 2 first non-zero entries in each of the rows. Remember, it's as you move from left to right. So the second condition is satisfied. So now, the third condition, remember it says that each leading one must be to the right of each leading one above it. And there's only one pair to check, so this leading one is to the right of this one. Of course, right? Because right means to move this way. To move this way. So this is to the right of this, and that's all you need to check for the third condition. So that's an example of a matrix that's in row echelon form. So the second example we're going to do is going to be a 3x4 matrix, because it's got 3 rows and 4 columns. And this one will have a row of zeros. So let's check that this matrix is in row echelon form. First condition up here says that all the rows of zeros must be at the bottom, and there's 1 row of zeros, and here it is at the bottom. So that first condition is satisfied. The second condition, the first non-zero entry of each row must be a 1. Let's circle them. for each of the first two rows, they each have a non-zero entry. So let's circle the first one. And then the third row doesn't have any non-zero entries, so we don't need to worry about it for the purpose of the second condition. So both of those entries that we circled are both ones, so the second condition is also satisfied. Lastly, the third condition, each leading one must be to the right of every leading one above it. So this is the only leading one that has a leading one above it, and it is to the right of this leading one.